So, good morning, everyone, and welcome to this lecture. This is lecture number 4 in rotation, and in the previous lecture, we have seen the different types of problem based on the equations of motion, where we have found out the angular velocity, angular displacement, angular acceleration, and such kind of things. Do we remember those problems? Yes or no? What we have already seen is whatever quantities we have in linear motion, or shall I call it translational motion, the same quantities we have in rotational motion. In linear motion, we had velocity. In rotational motion, we have angular velocity. In translational motion, we have acceleration. In rotational motion, we have angular acceleration. Every quantity in translational motion has a counterpart in the rotational motion. We have seen the counterparts of velocity, acceleration, and displacement. Now it is the next counterpart, the next thing coming, which is known as the moment of inertia. Moment of inertia. Now, what is moment of inertia? You must remember the word inertia. Do we remember the word inertia? What was the meaning of the word inertia? Do we remember it? Yes or no? Yes. The what was inertia? It was the property of a body by virtue of which it opposes any change in its state of rest or in its state or in its state of motion. Do we remember this? So if I just go back to inertia to understand moment of inertia, inertia is the property Inertia is the property of a body by virtue of which it opposes any change and now I will just use a different word, any change in its translational motion. Any change in its translational motion. If a body is in translational motion and you want to change the motion of that body, whether it is at rest or whether it is moving with uniform velocity, it will oppose this change. This bottle moving like this, or it is at rest like this. If I want to change its state of rest or state of translational motion, it will resist that change. That property of the body is known as inertia. Now, in the beginning, when we studied the word inertia, we did not use this term translational motion, but we should have used the term translational motion. But at that point, it becomes very difficult for understanding this part because we are quite young. Therefore, we did not use this term. But this is the actual definition of inertia. It is the property of a body by virtue of which it opposes any change in its translational motion. We understand this, what I am saying here? Now, if you remember inertia, inertia was measured by the mass of the body. Yes or no? Inertia is measured by the mass. If a body has more mass, we will say it has more inertia, or you will have to apply more force to the to moving the body. If a body has less inertia, for example, see this body, I have to move this body, this is empty bottle, it is easier to move it. But if I fill it with water, the mass becomes more, it becomes more difficult to move it. So inertia of a body was measured by its mass. Now, we have seen that there are two types of motion of a body. One is pure translation and one is rotation. And in rotation, the orientation changes. We remember this, yes or no? Orientation changes. Now, and we have seen that everything has a counterpart in rotational motion. Mass was doing the part of inertia in rotational motion, in translational motion. There was inertia which was preventing the body to change its translational motion. Therefore, in rotational motion, we have moment of inertia. So, what is moment of inertia? Moment of inertia, moment of inertia is the property of a body. Can you complete the sentence? Can you complete this sentence? Anyone? Can you try? Okay. Is a property of a body by virtue of which it opposes. Is it so difficult? Any change in, can you repeat, can you complete the sentence now? In its rotational motion. The property of a body by virtue of which it opposes any change in its rotational motion. Moment of inertia, MI, is doing the same job. Same job as what? Is doing the same job in rotational motion. It is doing the same job. Moment of inertia is doing the same job in rotational motion as what? As mass was doing in which motion? As mass was doing in translational motion. I'll give you 2 minutes. Please note it down. I hope we have understood this. 2 minutes. Note it down, please. Anyone understands this? Please note it down. Okay. So, moment of inertia. We were discussing moment of inertia. Now, let us see the type of quantity is moment of inertia. The SI unit of moment of inertia. The SI unit of moment of inertia is kg meter square. The dimension is ml square. Now, what type of quantity is moment of inertia? It is not a scalar, not a vector. So it is not a scalar, not a vector. It is known as a tensor. So it is a new type of quantity. Just remember that it is known as a tensor quantity. It is known as a tensor quantity. It's not a scalar. Everyone written this down? Not a vector. It is known as a tensor quantity. Now, what all factors this moment of inertia depends on? So write the next heading, factors affecting MI. When I say MI, that means moment of inertia. The first factor on which moment of inertia depends on is the size, shape, size, and the geometry of the body. What is the size? What is the size? What is the shape? What is the geometry of the body? It depends on the distribution of the mass. It depends on basically the distribution of mass relative to the axis of rotation. How the mass is distributed about the axis of rotation. It depends on the density of the body. If the density is more, the moment of inertia will be more. It depends on the axis of rotation. It depends on the axis of rotation for different different axes. The moment of inertia would be different. I hope you understand this. Moment of inertia does not depend on moment of inertia does not depend on the angular velocity or angular acceleration or any such things. It only depends on how the body is, what is the mass of the body, what is the density of the body, what is the distribution of mass. It depends on that. Do we understand this? Yes or no? No, yes. Now, one more point you can remember. If you compare the moment of inertia of a hollow body and compare it with a solid body, hollow body, same size, same shape, and a solid body, same size, same shape, same mass, which body will have more moment of inertia? The hollow body or the solid body? Solid body, same size, same shape, same mass, and a hollow body, same size, same shape, same mass. Which one will have more moment of inertia? The hollow body or the solid body? Tell me. Hollow body or the solid body? You have a hollow sphere. Same size, same mass, same radius, same everything. You have a solid sphere, hollow sphere, solid sphere. Who will have more moment of inertia, hollow sphere or the solid sphere? Which one? The moment of inertia of the hollow body will be more than the moment of inertia for the solid body, because from the hollow body all the mass is very far away from the axis of rotation. So the moment of inertia for the hollow body will be more than the moment of inertia for the solid body. Do we understand this? Okay. Please note it down. I'll give you 2 minutes to note it down.
Sir.
So we have seen the basic idea of moment of inertia. Now we head on to the next heading, and the next heading is moment of inertia of a point mass. So write the next heading, moment of inertia of a point mass. Moment of inertia of a point mass. What do you mean by moment of inertia of a point mass? So what I have done is I have drawn a few point masses m1, m2 and m3, and you can see one axis. This is the axis of rotation. Do we understand this? This is the axis of rotation. We can find out the moment of inertia of this point mass about this axis of rotation by the simple formula. Moment of inertia of a point mass about the axis of rotation is given by the formula mr square. So moment of inertia of this body will be m1 r1 square. The moment of inertia of this body will be m2 r2 square, and moment of inertia of this body will be m3 r3 square. Do we understand this? This is moment of inertia of a particle about any axis of rotation. The formula is simple. I will be equal to m into r square, where r is the distance of the particle from the axis of rotation. Do we understand this? This is how we find out the moment of inertia of a point mass. Moment of inertia of a point mass. This is how we find it out. Everyone understands this? Yes or no? No or yes? Okay, this is the moment of inertia. Now there is one more thing which is known as radius of gyration. So we can just remember this thing also. Radius of gyration, denoted by the letter K. What is this radius of gyration? Now we'll not go into the technicality of this thing. What is this radius of gyration? We will just write the formula of this radius of gyration. And how do you find out the radius of gyration? The first thing that you must remember, this radius of gyration K depends on the axis of rotation. Depends on the axis of rotation. About which axis the body is rotating and about which axis you are finding out this radius of gyration. It depends on this axis of rotation. So you have to find the radius of gyration about any axis. What will you do? You will find the moment of inertia of the particle about that axis, and you will divide it by the mass itself. So radius of gyration of a body about any axis is the moment of inertia of the body by mass ka under root. Do we understand this? Okay. First, I will just please understand those points. Then I will give you time. Then you can note it down. So, do we remember this? Will you remember this formula of radius of gyration? It depends on the axis. So, on different axes, the radius of gyration will be different. So, what are the factors on which it depends on? It depends on, since it depends on moment of inertia, it depends on point number one. It depends on the size and shape of the body, the geometry of the body, the position and configuration of the axis of rotation. Where is the axis of rotation? It also depends on the distribution of mass. So basically, if body is like this, or the body is like this, they will have different radius of gyration. If this body is of different mass, it will have different radius. Uh, if this body has different distribution of mass, it will have different radius of gyration. One very important thing, and you must remember this and don't forget this, moment of inertia depends on the mass. Radius of gyration does not depend on the mass of the body. Very important thing, it does not depend on the mass of the body. You can add one point. I think I have missed the point. In factors affecting moment of inertia, you can write point number 5. It depends on the mass of the body. We wrote everything about the mass, but we did not write the mass itself. It depends on the mass of the body. How much is the mass of the body? If the mass of the body is less, moment of inertia is less. The mass of the body, same body is more. Moment of inertia is more. So moment of inertia, MI, moment of inertia, depends on the mass of the body. But this gentleman, which gentleman? Which gentleman? Radius of gyration, gentlemen, does not depend on the mass of the body. What type of quantity this is? This is definitely a scalar quantity. The SI unit is meters. When SI unit is meter, the dimension is L. Do we understand this? Okay, now I'll give you 2 minutes. Note it down. Let me know once you are done. Okay, then let us move ahead to the next topic. The next thing that we have to understand, and that is moment of inertia of a system of particles. Moment of inertia of a system of particles. If I have more than one particle, more than one mass, how will I find out the moment of inertia? How will I find out the moment of inertia of more than one mass? For example, the same example that we have given, the same example that we had given. Let us say I have three masses, and I have a system of these three masses, and I want to find out the total moment of inertia of these three masses put together. So the total moment of inertia of this system, moment of inertia will be this system will be I1 plus I2 plus I3. So this will be equal to M1 R1 square plus M2 R2 square plus M3 R3 square. So basically I can write for a system of more than one particle, it is summation of moment of inertia. Do you understand the meaning of summation? Addition of all the moment of inertia together. Do we understand this? Pakka? Okay, I'll give you 2 minutes to note it down. So this is the question. Do you understand this question? We will discuss this in the next class, and I'll see you in the next class. Take care.
Bye, sir.
God bless all of you.